Assalamu alaikum, grade 6. Welcome again to the physics session. Today, inshallah, we're gonna talking about the lesson number 3 in this chapter 1 in your book physics. That's chapter talking about motion. And today we're gonna talk about the acceleration. That's new phenomena in physics, and that's important phenomena in physics. That's responsible for describing the two quantities what we talking in last session, speed and velocity, and we should know what the meaning of acceleration. Before going in this lesson, we should to watch this video, and I know that's your preferred in this kind of video, and that's video that describe the how amount or how huge the speed of the Ferrari car. Watch this video and absorb that what is happening in the car. Excellent. So this is video talking about the how amount of acceleration that this Ferrari car can do it for changing the speed for 0 kilometers per minute to per hours to 300 kilometers per hours, and this is huge speed. So this is meaning of acceleration. So what is the acceleration? You can watch or take a look. This is picture, and this is man that kick the ball and make it a change in the velocity in this is ball. So the acceleration then that at which velocity change. What's change? What kind of change? So inside acceleration refers in increasing speed, decreasing speed, or changing the direction. In lesson number 1 or lesson number 2, we talking about the difference between speed and velocity, and difference between them the direction. If I put the speed and direction of speed called velocity. So we have 3 kind of change in velocity. Number 1, increase, decrease, or changing the direction. And we should to know what is the equation we can calculate the acceleration. Acceleration equals final speed minus initial speed by time, and we can remember the unit of speed is meter by second. Now another second by this is time, so the difference here in unit for acceleration. Unit of acceleration, the acceleration tell you how many meters per second your velocity change in each second. So A, this is symbol for acceleration, equal delta V by delta T. That's the changing in velocity by changing the time. Velocity means meters per second, and the time is second. So second and second be second squared. So the units of acceleration is meter per second squared. So this is units are usually written as meters per second squared. So all of you now understand the acceleration and how we can calculate the acceleration. And this is lesson we're talking about the acceleration, how we can calculate the acceleration, and the graph of acceleration, how can make the graph for acceleration. And this is 3 kinds of changing the velocity. Number 1, increasing. the velocity, like kicking the ball, and blocking the ball, that's decreasing the velocity of the ball, and this is to change the direction of speed. So all of this can be acceleration, or the phases of acceleration. Now you can open your book, page number 18, and answer with me. This is problem in math or physics. That's how can calculate the acceleration in something. So large, you can read with me. Large acceleration are part of the throw in many amusement park dirt or rates. The problems below are based on actual museum work. Right. Calculate number one and number two. Number one, that we can one type of radio falls straight down for 30 or 3 seconds during this is time. The rate accelerators from a speed 0 meters per second to a speed of 30 meters per second. What is average of acceleration of rate? So initial 0 speed or 0 meters per second. Final is 30 meters per second, and in time 3 seconds. So we can calculate the speed, the acceleration, final speed minus initial speed per time or in time. So 0 or 30 meters per second minus 0 meters per second in 3 seconds. So that's meaning equal 10 meters per second squared. That's the amount of acceleration. Do you understand that? Okay, we can go to the number 2. A roller coaster accelerators from a speed of 4 seconds or 4 meters per second to the 22 meters per second in 3 seconds. What is the average of acceleration rate? So initial speed 4 meters per second, final is 22 meters per second, and time is 3 seconds. So that's like what we do in problem number 1. Final minus initial per time. So 22 minus 4 per 3, and this is equal 6 minutes per second. So I hope you understand how we can calculate the acceleration. You can write it and do the question in worksheet. Now we can going to the another or next step in this is lesson. How we can do graph acceleration. You can use both speed versus time graph and distance versus time graph to analyze the motion of an accelerations or acceleration object. So we have graph between speed or time versus time, or distance versus time, and this is the slope of the speed versus time graph is the acceleration. So acceleration, that's meaning the slope. That's what we're talking about in lesson number 2. So the slope between the speed and time in this is line, that's called acceleration. So the standard straight line on speed versus time graph means that the acceleration of the object constant, but not zero, not equal 0. So if the line slants upward, speed was increasing. If the line slopes downwards, speed was decreasing. So this is line, it's upward or slants that upward, so the speed is increasing. And if the slope downwards, or this is line going downwards, speed was decreasing. So that is how we can make a graph for acceleration. We can watching that video that describe what we're talking about.
Graphing acceleration. Suppose you bike down a long, steep hill. At the top of the hill, your speed is 0 meters per second. As you start down the hill, your speed increases. Each second, you move at a greater speed and travel a greater distance than the second before. During the 5 seconds it takes you to reach the bottom of the hill, you are an accelerating object. You can use both a speed versus time graph and a distance versus time graph to analyze the motion of an accelerating object. Analyzing a speed versus time graph. Refer to the graphs as the bicyclist moves down the hill.
So you can watching the change the speed
What
in
can
the
you learn
bicycle.
about your motion by analyzing this speed versus time graph? First, since the line slants upward, the graph shows that your speed was increasing. Next, since the line is straight, you can tell that your acceleration was constant. A slanted, straight line on a speed versus time graph means that the object is accelerating at a constant rate. Your acceleration is the slope of the line. Analyzing a distance versus time graph. Look at this distance versus time graph. The curved line tells you that during each second, you traveled a greater distance than the second before. For example, you traveled a greater distance during the third second than you did during the first second. The curved line also tells you that during each second your speed was greater than the second before. The slope of a distance versus time graph is the speed of an object. From second to second, the slope of the line in this graph gets steeper. Since the slope is increasing, you can conclude that your speed was also increasing. You were accelerating.
Okay, I hope you understand that. Okay, I hope you understand what this video said and describing how we can making a graph of acceleration, and that is last point in this session. So now we can talking about how we can make a graph for acceleration, and as we will be talking the acceleration between two variables, that's distance and time, that's describing the speed, and the speed and time, that's describing the acceleration. So we can make this is graph easily, and this is in your site, you can do it in person, and that's we have table that describing the amount of speed increasing by increasing the time. Number one, 0 time and 0 speed. So the bicycle we can put it here. So that's 0 in 0 time, the speed it will be 0. Number 2, in second number 1, the speed 2 meters per second. So 1 2 speed and 1 time, so you can put it here. Speed 4 and time 2. So speed 4 and time 2. Excellent. Speed 6 and time 3. Excellent. 4 and 8. And 5 and 10. Excellent. So we drawing this is line. This is line describing the acceleration and how amount the raising of speed by time. we can getting the slope for this is straight line to make the amount of acceleration. And this is another graph for describing the amount of speed by distance and time. So 0 and 0 like this, 1 time 1 meters like this. So here this is problem. Here 1 and 1, and we have done 1 here in the this is variable, so we can put it nearly like this. Okay, you can put it nearly 1 here, not 1 in here, that's like 1 just here. So 2 times and 4, so we don't 4 here, so we can put it nearly 5. Okay, and 3 and 9, 3 and 9, put it nearly 10. 4 and 6 above the 50. Okay, and 5 and 25. Excellent. So you can show how the reason of this is line and the slope, so that's describing or increasing the acceleration. Excellent. I hope you understand how we can do the graph of acceleration and calculate the acceleration from the slope. Any question you can tell me in your WhatsApp, and I want you to answer the worksheets and study well and read the session or read the lesson again. Thank you for listening, and goodbye.